So we are going to kick it off here, and our guest host is joining us video virtually. So we have a video from Kristen Graham of NYSERDA, and she'll be talking a little bit about the context for this project and introducing our great speaker.
Hi, I'm Kristen Graham. I'm a project manager in the new construction program with the New York State Energy Research and Development Authority, or NYSERDA, the state's clean energy agency. I'm pleased to join you for tonight's Global Passive House Showcase on the Rheingold Senior Housing Project. These weekly discussions focus on successes, strategies, incentives, and goals for accelerating building decarbonization and optimizing carbon neutral design and construction. Over the past year, the showcases have become one of the cornerstones in the partnership between NYSERDA and the Passive House Accelerator. NYSERDA and the Accelerator are collaborating on efforts to support building industry stakeholders and advance the Passive House community while showcasing replicable and scalable solutions that are desirable, affordable, easily operational, and comfortable for occupants. New York State has the most aggressive clean energy and climate agenda in the nation, as outlined in the Climate Leadership and Community Protection Act, or the Climate Act. The Climate Act has set the goal to reduce greenhouse gas emissions 85% by 2050, putting New York on a path to economy-wide carbon neutrality. Buildings are responsible for 1/3 of those greenhouse gas emissions in New York. Focusing on larger buildings within growing market sectors will increase scalability of solutions and maximize our impact on the state's building stock. The multifamily sector represents about 40% of projected new construction in New York State by square footage. NYSERDA's $40 million Buildings of Excellence competition is supporting the transformation of the multifamily sector by recognizing the design, construction, operation of carbon neutral multifamily buildings. Since the launch in 2019, we have gone from working to prove out the technical viability of decarbonizing multifamily buildings to having innovative building solution sets that are viable and cost effective. The 2 rounds of the competition have awarded over $31 million to more than 40 projects within both market rate and affordable housing communities. 28 of these projects are set to follow a passive house performance path, and all 14 projects awarded in round 2 are slated to be all electric, including the first proposed super tall project. Round 3 of the Buildings of Excellence will launch soon, and we are looking forward to continued success in the market. In today's showcase, you will hear about one passive house project from the first round of the competition. The Rheingold Senior Housing is a 94-unit affordable senior housing project located in Brooklyn, New York. We're excited to have Sarah Beyer, Associate Principal and Director of Sustainability for Magnuson Architecture and Planning, here to share lessons learned, solution sets, and how the commitment to passive house design and verification principle provides the occupants with superior indoor air quality. Magnuson has shifted their project portfolio to be carbon neutral while continuing to prioritize equitable, comfortable, and healthy spaces for all building occupants. This mission is a key component found within all 8 winning Buildings of Excellence projects that Magnuson has been part of. Thank you again to Sarah for providing more information on this innovative project, and I wish you an informative and interactive session.
All right, thank you, Kristen. And with that, Sarah, please take it away.
Okay, thanks for having me, everybody. Let me share my screen. Yeah, thanks for having me, everybody. I'll give you a brief summary and some highlights of this Buildings of Excellence Round 1 winner, Rheingold Senior Housing. If the slides will advance. Okay, so MAP is designing affordable housing in the greater New York City area. And we've been tracking our portfolio over the past 10 years, comparing it to the baseline of code, which is the black line at the top of this source EUI chart. And our BOE winners are logged here with their site and source EUIs and Rheingold seniors. You can see it's from 2019 when we designed it. We are trending, we see this as part of, we see the larger trend here from this chart of a progression towards lower source EUI towards net zero operational energy. And we're also tackling the embodied carbon question. So we're committed to this, to reaching those goals, but it's still a work in progress. The senior building has studios and 1 bedrooms. And we are going to talk about, I'm going to kind of touch on how we're balancing sort of not competing, but different aspects of the building with passive house targets. So balancing passive house targets with cost, balancing with embodied carbon considerations, and balancing them with a dense senior building. The site is in the former Rheingold brewery in Bushwick. And these are our metrics. You can see that when we designed, the code was 2016, and what the EUI would have been for a code baseline building. So you can see how much of a greater improvement the passive house targets are getting us. But this being a dense senior building, and we were targeting FIAS 2015 certification, we aren't quite able to meet the source energy target. All the other metrics, the peak heating and cooling, we're able to meet, but this being a very dense senior building with lots of appliances and plug loads in a small footprint, that is the reason, one of the main reasons we won't be able to certify. Also, if the grid was significantly cleaner, we could also probably certify, or if we've reduced our window to wall area ratio, which is currently at 27%, but that would have been a bit infeasible for this project. Even though we can't certify, we've incorporated all of the quality control measures of passive house into the project, so that we can achieve the lower EUI. This is a quick summary of the thermal enclosure, which is not that much more robust than current 2020 code in New York City. We have adopted a stretch code here in the city, so those R values are getting more robust and more reasonable for what we really need. We might even look again at this R50 roof value. We might be able to reduce that a little bit. We're seeing in our other passive house projects that we're able to reduce that a bit because the form factor is so good, and we have such a internally load dominated building. Another interesting point here is that the air tightness in the code, actually for each component, but taken by itself, could meet the passive house targets. But what makes passive house different is that all of these really tight components together have to meet that total air tightness. And we also, don't need triple pane windows usually in these internally load dominated buildings. We would need it sometimes for the comfort criteria, but I think between the standards and the different versions of the standards, that comfort criteria is changing. So we like to balance the embodied carbon of that triple pane glazing with the operational and comfort criteria. So most of the time we don't do triple pane. One of the wonderful things about passive house is the increased relationship and the deepening of the relationship between MEP engineers and architects. They really need to rely on our passive house envelope to right size their equipment, and that makes for a better collaboration. So this project will be almost all electric. We do have an alternate for using a heat pump to make the hot water, which is becoming a pretty standard consideration in most of our projects. We have a fair number of them in the office with that air source heat pump. So balancing cost with passive house, it really depends on what baseline you're looking for. So for this project, we were targeting the same systems that you would need for passive house, the ERVs and the VRFs. And in our typology, we have enterprise green communities. which is very common in the States for affordable housing, and especially in New York City, where we have to be 15% better than code in terms of cost of our energy use. So with a great baseline in those systems, we knew we wanted to have a healthy building. So VRFs and ERVs were critical for that. We had this sort of list of all of the specifications that would be involved in addressing energy use. So all of these specifications, we would have to tweak slightly between the sort of baseline, which is a little bit better than code, and a passive house alternate. And we gave this passive house alternate to 4 contractors, and they came back with a price difference of only 1%. And the biggest savings was in that relationship between the envelope and the systems, where the condensing units for the VRF actually were able to be 20% smaller in the passive house option. So that was a critical savings we were able to capture and show actually the annual cost savings, which convinced the client to go to passive house. This is our typical floor plan. We have these interlocking studios, which I'll show you in a second, a little bit greater detail. We take advantage of the space behind the tubs where 2 bathrooms come together to run our vertical ERV shafts. We often do this design move in our senior housing to have a nice lounge at the corner where the stair and the elevator are, which actually contributes to part of our zoning requirement for senior housing to have these amenity spaces. Of course, it's important to make sure everything is stacked nicely. You don't have a lot of offsets. That saves operational and embodied carbon. And here's a view of those interlocking alcove studios. With senior living, it's critical to try to give a studio apartment in particular a variety of spaces so that people can live perhaps with an attendant, or 2 people can live in a studio together. Another important aspect I wanted to mention here that's required by enterprise green communities, this affordable housing baseline, is apartment compartmentalization, which reduces stack effect in a large building like this, and also contributes greatly to the healthy interior of the apartment, reducing smells from your neighbor. And it's actually pretty much required by code to do anyway. It's just another kind of quality control aspect that, we're also kind of the same concept with the exterior envelope. When designing the VRF system with the evaporators in the units, the condensers on the roof, there are a lot of considerations when using them in this typology that you want to think about. Normally the landlord pays for heating. How do you bill for cooling? Because the units are, the condensers that use the most power are on the house meter. The evaporators just use a little power for the fan in the unit. So normally we have like a third-party billing system that does the cooling, or the owner pays for cooling, which is about $40 a month or so, depending. Another consideration is to try not to give as much flexibility in terms of the mode of the unit. So in heating or cooling, and we do that by creating zones by facade. So for the facade, for the environmental exposure. You really want to watch quality control of your condensate during construction. Those pipes can, if they get kinked, they can cause issues. And you can place your evaporators close to the exterior or in a little bit. And we use wall-mounted ones instead of ceiling-mounted ones, because we have pretty tight floor-to-floor heights in our typology. And usually so we don't have a drop ceiling to place them in. And I'll get into it a little bit more, but the refrigerant distribution is a lot more efficient in this sort of vertical riser condition. So this is our top floor. showing that we have an occupied roof on the west side of the building. So in order to get from the evaporators to the condensers, which are all located on the east or the right side of the building, you have to have these offsets. And so this is kind of showing this concept of how much more refrigerant and how much more refrigerant lines you're adding if you're not really thinking through early in the design how the evaporators are connected to the condensers. This is another project that is exploring heat recovery as an option, which is something that is perceived to give more occupant comfort, or but in the end, we find other ways of doing this, of giving that control by zoning the facade. And it doesn't, in energy models, it doesn't save that much energy. And you can see how much more refrigerant and potential for leaks there is with that kind of horizontal distribution. This is the cladding design, which is using the thermally broken girts and spacing them according to the size of the mineral wool insulation, so that it's quicker to install. There's less penetrations attaching the insulation to the backup wall, and it's thermally broken. And the cladding design, the spacing of the windows is based off of, like, the space between the windows is based off of the size of the cladding, to minimize the amount of cuts of the material. Actually, this product is the waste cut from their other manufacturing processes. And the design here is to not have to create shop drawings, but just a pattern, so that makes it easier and cost effective. A lot of our structures are block and plank, which is CMU block and precast planks that span like about 30 feet. But in this building, we have, you might have seen in the plan or noticed that we have a single loaded corridor where the lot is really shallow. So we have this sort of steel framed facade where we have some public space next to that lounge. And that steel frame facade kind of gives some, we really worked hard to keep that steel off the face of the building so that we could give more, give a nice clean surface for the air barrier to be applied to without a lot of ins and outs and things to overlap. And so it's difficult with this. The structural engineers really like to line up that steel I-beam with the center of the CMU of a parapet or the walls above, for example. You can kind of tell, I'm sorry I didn't draw a center line, but they're offset. This is a view of our sill and jamb using the same size. The size of the panel, actually, it fits perfectly with the jamb of the window. So we were able to cover the jamb with that panel. And lastly, just a short note about embodied carbon. You've probably seen that we're using mineral wool, which has lower embodied carbon than other foam choices for rain screen. But this product we're extremely excited about. It replaces two products, the gravel layer and the subslab insulation, which could be typically foam. It's a recycled glass aggregate. It unfortunately has the word foam sometimes in its name, but it's low toxicity. It has about an R2 per inch. And on this project, we actually needed an SSDS system, which subslab depressurization. So we needed to have some airspace in that gravel layer in order to control the vapors so that they wouldn't get into the building. So they're sort of funneled into these tubes and then out through a fan on the roof. So we went through the Office of Engineering Remediation to get this foam glass approved as instead of the gravel layer, which would normally provide that airspace. But at the pipes themselves, we actually need to have that true gravel around the pipe, and then we can have 2 inches of the foam glass above that, and everywhere else the insulation of the foam glass. And that's it. I hope I didn't go too fast or too slow.
That was perfect.
Okay.
It was great. So we'll just take a second. Zach, you want to go to sponsors?
Yes, I do. And I want to start by thanking NYSERDA for helping to make this project possible. And then Kristen alluded earlier to the partnership that we have with NYSERDA and the role that these showcases play in it. So our work is thanks to that support and support from our other sponsors, including our founding sponsors, 475 High Performance Building Supply, Baxtingwe Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwool North America, Stocorp, and Zola Windows. Our champion sponsors are Icon Windows and Siga. And thanks also to our patron sponsors, Aero Barrier, BR+A Consulting Engineers, Brennan Airtightness and Insulation, Euroline Windows, Inotech Windows and Doors, Lamelux, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thanks.
Excellent. Thanks, Zach. So we're going to dive into questions. I'm working remotely, so bear with me if I miss you. So we have Jeff, Scott, Mark, and Zach in the queue. And so we'll go to Jeff. Over to you, Jeff. And then Julie's added in.
Is it me, Jeff?
That's you, Jeff.
Hey, Sean. Hey, everybody. Hey, Zach. Hey, Sarah. Thank you. Beautiful project. I am really looking forward to the day that you guys can use mass timber for your structures. I don't know how much familiar you are, but I presented to a lot of you folks, maybe 4 years ago, and the code just hasn't. Our city is so backward. It's so effed up. pH upped, I meant. But anyhow, my question was about the exterior cladding system. I really just didn't see, looked like a rain screen, looked like tight to the rock wall. I just didn't see what the material was, what the system was. Forgive me, can you tell me that?
Sure, it's fiber reinforced concrete, glass fiber reinforced concrete.
So it's GFRC?
Mm-hmm.
GFRC strips?
Yeah, the waste cutoffs from their larger panels.
Oh, isn't that interesting? How's that price?
A little cheaper than the full-size panel. I can't give you a number off the top of my head. I mean, it keeps changing.
Everything's changing.
Yeah, I can tell you the gray colors are more cost-effective than the red colors, which is, you might have seen older diagrams had the red instead of the great's gray now.
Do you ever use like hardy board or cement board in the city?
Yeah, I've used like the lighter density hardy board, and Allura is another one, fiber cement products.
And would you say the GFRC is comparable? How's it priced compared to the hardy board? Since you use
it's a bit more expensive, but I think it's more durable, more impact resistant.
Could you somehow post the name of the distributor or system or something so we could reach out?
Yeah, sure.
Thank you.
Yeah.
All right, Jeff. Thank you for those questions. And we're going to go over to Zach. Or sorry, over to Scott Kennedy.
I just had a couple questions. One was, what did you use for, maybe I missed it, but the ventilation of the suites, the HRV or ERV? It looked like it was something on the roof, central. Is that what it was? Yeah,
it's centralized ERV. Yeah.
And is it one big one for the whole building, or each stack has one?
Two. Since the core is in the middle, it was really difficult to transfer through that core, and the occupied roof on the west side. So there's one piece of mechanical equipment on the west side in the landscaped occupied terrace is that ERV behind a nice wood screen.
Same problem we were having. Okay. The last one was, I noticed you did that under slab negative venting. And is that pipe run inside the thermal envelope or outside the thermal envelope? Did you deal with it as a thermal bridge? That comes up a lot on our project.
Yeah, so the pipe, I think there's just one pipe that goes through the building, actually through the thermal envelope in the slab and then out the roof. And so we kind of deal with that like any other pipe ventilation penetration. But the air vapors are all outside the thermal envelope,
Right.
under the slab. And
Yeah, so we've been treating that like a thermal bridge. So it has to get insulated all the way up, or because there's air continuously moving through it. That's proved a bit of a challenge on a couple of projects. Yeah.
Yeah.
It's just like a plumbing, we treat it like a plumbing vent pipe, right? So, yeah, and we're finding those losses are pretty significant plumbing vents. It's at least 1 kilowatt-hour a square meter per year. We're thinking metric here. So. Anyway. All right, thanks.
Thanks, Scott. And Mark and Julie may have had the same question, but Mark, you get to go first.
Well, then I'll save it for Julie, but I'll state that, Sarah, I really appreciated how you mentioned that the envelope was allowing the mechanical to be a period of savings for a building of this size. I think oftentimes that's assumed by a lot of folks in our community, but it's not stated so clearly. So for bringing that forward, I say double thumbs up. Thank you very much.
Double thumbs up.
Absolutely. All right, Julie. Mark, save the question for you.
Thank you, Mark. Yeah, we were looking at aero aggregates, glass foam insulation instead of foam. We got a price from them at about $125 a cubic yard versus about 50 something for foam. So I'm just curious how we make that pencil out for projects.
Well, when we priced the alternate, it was about $20,000 difference for the whole project between the foam and the foam glass. I'm just going to call it expanded glass. But that was a couple years ago. So I don't know what the effect the market is having, and maybe that really high demand. There's only 2 manufacturers in the Northeast, I think, as far as I can tell, gravel and aero aggregates. So
yeah, they were talking about opening a plant actually in our town here. So I thought I could get them to donate our slab base, but they're not up and running yet. So they would be shipping it, and that's a shipped price, but it's hard to make that work, at least right now. So
Just to add a little bit to that quickly, we priced almost 500 yards for a project in New Haven. They're quoting gravel. This is 15 to 20 bucks to ship it. Total cost around 80. I'm not talking about a yard. Total cost 80 bucks a yard. We had 6 inches of gravel and 3 inches of EPS. The gravel solution gives the same R value for a slightly lower cost.
yeah, I was figuring we'd need 16 inches of gravel. Are you running shorter than that to get like an R20?
Well, if you need R20, that's more than we needed.
Okay. All right, thank you.
Excellent. Thanks, Julie. Thanks, Jeff, for popping in there. Ferd had a question. Ferd, I'm going to change your name. It's going to be P-H-E-R-D. Ferd?
I think Ferd just left.
Okay.
Maybe.
All right.
Yeah.
All right, Zach. We'll go to Shannon.
Hey, Sean, thank you. Sorry that took me a minute. I actually was wondering which foam glass gravel you used, and if you mentioned it, apologies in advance. But before you answer, thank you for showing this project. It was really great to hear the way that you optimize the spatial, the systems, the way you offset the structure to, make the sequencing smooth and the thermal breaks minimal. Bravo, beautiful project, really nice presentation.
thank you, Shannon. Yeah, we specified aero aggregates.
Thank you.
And they were so great to work with to get that SSDS approval for that, the OER, which I guess hadn't been done before with them. It's great.
Thank you.
I do, yeah. I did
Thanks,
want to
Shannon.
mention one thing
Oh,
about
go ahead.
oh, no, I just was going to follow up if about the wood that Jeff was mentioning, CLT. I just finished came off a presentation at Nessie about embodied carbon, which I just briefly touched on today, but you know, we have I'm not sure we have a worldwide a good enough relationship with forests and wood to really be using a ton more wood. But I think it's an amazing moment we have right now with all of us looking at it, people that weren't necessarily looking at forestry practices before in this building industry and asking for those better forestry practices. Because I think,
Well, Sarah, if I can just comment, Sean, if you don't mind, that idea of how much sequestration happens in which forests using what certification systems is getting a lot of attention, just like you said. There are ways to measure it. All the guys that, you know, provide material to the US have one certification or another. And, you know, the embodied carbon of a building is 50% its superstructure. If you're using healthy bones, you're making a big contribution towards decarbonizing the building materials. And you can do it. So I'm glad you're interested in that.
yeah, I totally agree.
Yeah, and Sarah, there's definitely lots of people like Jeff on that regular show up that are wood lovers and are definitely can help out in that regard. So it's excellent that it's now on all of our radars and trying to figure out how to make those solutions. Zach, I think we're over to you for a question.
Great. Yeah. So mine is pretty open-ended, Sarah. And it has to do with I think part of the reason that NYSERDA is doing the Buildings of Excellence program is to show like proof of concept and to share lessons learned and all that. So I guess what were the lessons that you will be bringing forward in the next phase of Passive House work at Magnuson? Like, were there things that you would avoid doing, or were there like breakthroughs that you expect to see in all the future projects? What are a couple of things that insights from this project that you expect to see impact Magnuson's work?
Oh, open-ended questions.
Yeah, sorry.
Okay, I can go on for a couple hours. But I think, a few things like that's the steel in our buildings. We have so many details with it. The fireproofing, it's interruption of the air barrier in our typology is so common. It's just kind of overlooked. I think we really need to look at that. We're really interested in unitized heat pump solutions as well, which we're really hoping we can also use on retrofit projects and to replace all the refrigerant running in our buildings. Yeah. So the leakage rate, I put the leakage rate there, that even with the vertical distribution of refrigerant, the amount of leakage in 10 years is equal to the embodied carbon of our concrete foundations.
Wow. Yeah.
Yeah. And that's just like typical leak. So, and the way to optimize like not having refrigerant leaking, just not having as many fittings, like you talk about that in ductwork too, right? Not having so many connections and keeping everything as straight as possible. And then, other lessons learned are, really having, you have to pretty much do a lot of other things very efficiently in order to be able to propose some of these things that are slightly different to your clients and to contractors. So it really helps to like have good systems in place in your office to do everything else smoothly. And, just talking to the whole firm, I mean, that's a really important part of the work that we do, where we try and we talk about how collaborative we are and how much we talk to each other, because and this is just like this community. I mean, you know, just talking as much as you can and having, you know, open questions and really being honest about your questions. Like you disseminate information and learn so much in the process.
Yeah, thank you. You know, that efficiency point is a really important one, I think, and it's sort of analogous to Mike Steffen from Walsh Construction, based in Oregon and Washington, talks a lot about efficiency, and he's talking about floor efficiency and thinking about how to be really efficient with your architecture in order to sort of buy yourself space, virtual space, to convince a client to move to Passive House, and also to drive down cost enough that it's something that works. But that notion that the same thing applies to business practice and delivery is, I think, a really important one. So thanks.
Excellent stuff. So in the queue, we've got Scott, Brian, and Jeff. So Scott, over to you.
I was just wondering if you had looked at distributing energy through the building using water rather than using refrigerant, and what kind of a cost premium that might give you.
Yeah, I've been asking some of our favorite mechanical engineers to like what we could do to distribute hydronically, and you know, I think a couple of Passive House projects are actually doing that, where you know they're just using regular hydronic baseboard, but they have a gas burning condensing boiler to do that. And I'm hoping that the day comes where we can have air source that could swap that out. Or we just get really, really good at running refrigerant and have really great quality control around that. I mean, there's so many things we could do better about that too, because, you know, really doing the refrigerant charge testing before you put the insulation on, so you can see where the leaks are, and, you know, making the connections to all the equipment, putting the insulation on that when it's exposed to the sunlight on the roof. You know, I think they're getting like sensors into the VRFs now as a matter of course to detect refrigerant leakage. But yes, that the hydronic solution would be great. Yeah.
But you don't have any costs associated with it. You haven't looked at that yet.
Yeah, I mean, I think it does cost less to do the hydronic baseboard. I don't know how much less, but yeah.
Okay, thanks.
Thanks, Scott. And Brian Icemart, you're next.
Hey everyone. It was just basically a feed on from Scott's question. We live in a hot climate in Perth, and we use refrigerant on split systems in residential. And when you do LCA, life cycle analysis, it kills it. I'm just like, does anybody know of any solution that anyone's working on in the background to replace it? I know its efficiencies are extremely high, and that's why we use it, but it would be great to get some kind of a solution so that we could delete it and not use it.
Yeah, I think they really are looking at lower global warming potential refrigerants, and they're going to be allowing some different ones in like our area, I think, the New York area. I think the issue is the flammability of those alternates, but that would help a lot. But also like really getting contractors to have more quality control around the brazing. It's copper brazing. It's a pretty common thing, but that would really help. And then the unitized options, like we're seeing in our New York City market, people are realizing there's this local law 97 market to retrofit and put in efficient heat pumps, and a few unitized options are coming to our area. You know, that reduce all that refrigerant running through your building. You just have the refrigerant like an air conditioner just like at the unit in your room.
That'd be good. Be a lot less refrigerant then, wouldn't it?
Yeah.
Thanks,
Brian. Hope your Thursday morning is going well. Thanks for joining us from across the pond.
Yeah, we're into it.
All right, Jeffrey, over to you.
Am I the director you talking about or somebody else?
You.
All right. So I guess this has been wonderful. I'm wondering though about kind of more of the team dynamics and the team processes that you use to achieve this, what I think is a wonderful result. What do you think you did right as far as getting the right, the people involved at the right time and that kind of thing versus if you looking back, and this is Monday morning quarterbacking, if you could change one or two things, what would you have done differently from the sort of team collaboration that you think could have either smoothed the path or made it that much better? Sorry, I'm a process.
Yeah, I mean that the process is so very important to make this stuff really happen. You need to have dedicated people that are just driving to ask questions and want to get to the bottom of things because yeah, there's so much to know about and this is all changing so fast. But one thing we did was have the contractors bid on a passive house alternate before they get the job. I mean, there are different strategies about getting a GC on board early and having them advise you, which I think is very useful for certain projects. But we kind of knew what we wanted to do. And we really wanted to study what this sort of, especially in 2018, like what this idea of, oh, passive house costs so much more, really like how to get to the bottom of that. So I think we broke down the differences in really like exact detail as much as we could, like what the difference between our baseline with the same systems and then this robust air barrier one with the reduced mechanical size. And then we gave that to all 5 contractors and 4 of them bid. And I think that was one of the smartest things that we did to really understand the cost.
So did you actually have like 2 sets of specifications where you had, this is kind of like the typical specification and this is the passive house specification?
Yeah, all those things I listed on that one slide. We had an Excel chart that listed the baseline, the passive house alternate, and then like a passive house alternate without certification, which just meant like basically less paperwork. We're just still doing the same quality control. So yeah, we had the specs on each of those, like the air tightness level would change, or the U value would slightly change of the windows, or the thickness of insulation on our hot water pipes would change. As detailed as we could get.
That's it. So you actually got from the bidding contractors 3 numbers for each scenario. Is that something that's shareable? At least even in some kind of summary form? Because that's fascinating.
Yeah, I mean, the actual numbers probably won't mean too much anymore, given that things are like interesting now, even more than usual. But yeah, I'd be willing to share that, what the differences were. Yeah,
that would be really, really cool. And I don't know how you do it, and I'll leave it up to Zach and Sean to figure that one out. But I'm sending an email to Zach about this question, so I'm done.
So I saw a couple more questions. Jeff, I love a spreadsheet, so we'll figure this out. It's just getting great data. Jeff, we're going from you. We're going to go to Enrique. Enrique.
Yeah, I just wonder, I mean, if you have some, Zoe was just posting some sources, whether, how do you compare those, the impact of the refrigerant leakage? I just attended a couple of weeks ago, the main passive house forum. And one of the questions I posted was the concern about the leakage. And the argument that I get, or I got, was that the leakage, I mean, is so small that it really is not really a concern, but given that the gas is like 2,000 times more global, has 2,000 times more global warming potential than the CO2. I think it's a concern. And my concern is from my own experience, because the first heat pump that I installed required 3 times the replacement of the refrigerant because it was leaking, and nobody was able to find the leak, but it was losing the refrigerant. So I guess my case is not unique. Probably there are some more. And how do you calculate the leakage that you compare there from one installation system or method to the other, the vertical to the horizontal?
Yeah, so for that, I had help from our energy consultant who is referencing a study in Germany, I think, where they gave us, and I put the amount of refrigerant per foot, I think she had, of expected leakage, the leakage rate from that study in that slide. So I think there are accurate studies out there, and then EPA has a percentage leakage rate of refrigerant charge. I forgot how they calculate it. But yeah, the EPA has a standard way of calculating the leakage rate.
Because the argument that I'm hearing is that those are kind of scary kind of news from the gas and petroleum industry to really, scare people away from heat pumps. But I think the situation is real, so it's something that we should take into consideration until we find really other type of refrigerants that do not cause so much harm.
Agreed. Yeah, and there's a lot we can do right now to minimize that risk. If we acknowledge that there is a risk, we can really start to address it. But they are just so much more efficient than a fossil fuel fire. They're 3 times more efficient. So at least because they're not generating heat, they're just moving it around.
Thank you.
Yeah.
Excellent, thanks. Sarah, hold on a second. We're going to go to Zach for some long list of events. It's a busy month of October.
Okay, thank you, Sean. I'll try to make it entertaining. It is entertaining. The first one I have to announce is that our own Shannon Pendleton is featured as the guest on our Passive House podcast episode this week. She talks about the history of green building kind of practice and organizing that's been going on in Philadelphia, as well as ideas around the power of an open network, open. You're gonna have to listen to hear the acronym. I don't remember it, but it's an architectural network of information and the power that could have to transform practice. So we also are doing a bunch of short bonus episodes right now based on interviews that I conducted during the International Passive House Conference, and one of those is with Benjamin Crick. There are several others, so please check out the Passive House podcast and take those in. Tomorrow, and I'm going to send the registration link right now. Tomorrow we have a Passive House component spotlight with Rockwell North America. They'll be talking about stone wool solutions for Passive House and drawing from large projects like this, the Cornell Tech Tower shown here in this image. Please join us tomorrow at 10 a.m. Pacific, 1 p.m. Eastern for that component spotlight with Rockwell. Then next week on Construction Tech, we have Prefab Experts Hive Mind at Construction Tech. So this will be a FIASCON Prefab panel sneak peek. So we're going to have a bunch of panelists from this really exciting prefab panel that will be happening at FIASCON. Join us on Tuesday to share some insights with us and have a conversation about the latest and greatest in prefab passive house delivery. Then, and speaking of FIAS, where's my cursor? Okay, so then FIASCON is next week. I'll be there. A whole bunch of people on the call will be there. I think a lot of folks who are here will be presenting as well. It's going to be in Tarrytown. This is in person only. So if you wanted to take in the great programming that's going to be at FIASCon, please join us in Tarrytown, New York. If you're close by, you can also just come for a day. There are one-day tickets. So we hope to see you there. Then next Wednesday, Vancouver Fire Hall 17 is the focus of our Passive House Showcase. This is, I think, the first Passive House Fire Hall in North America. Lots of interesting technical challenges and solutions to take in on that. Okay, and then I'm going to change to a different thing. We've got this fun. We've been working on another project, and we're going to do a little teaser video. All right, so set your calendars or mark your calendars for October 28th at 2 p.m. British Summer Time, which is 9 a.m. Eastern and 6 a.m. Pacific. We're going to be doing a UK and Ireland-based program once a month. We're really excited about it. One last thing, we have a new homepage. So we've revamped our homepage to really focus on all of the cool content that is being shared at the Accelerator every week. So this is a place where we're hoping that this will be easier to access the latest videos, the latest articles, and the latest event announcements. So I just wanted to let you know that that's the case and encourage you to explore around. And if you have any comments or notice anything awry, please let me know at Zach, Z-A-C-K, at PassiveHouseAccelerator.com. Thank you.